Find the quadratic equation that best fits the data below. Make an XY plot and insert a trendline equation. Now, given this data, I've copied into this, so let me expand this so that it will be visible. Now, this is the equation. Now, I want to insert the graph XY plot. So we'll just select okay, this. Now add these values. Just copy that as a picture. So let me insert the values here. Have minus 2.5 minus 1.6 3.2 4.1 this is 9.5 4.5 that's 7.5 55 So let me delete this. Now we needed to find the quadratic equation that best fits this data. So how to find it using XY plot? So we just select this information, this data. Having selected it, we just go to insert tab. We'll go down to this place, this scattered, insert scattered XY or above this. Now we use X. Having drawn this, we'll just come to this plus sign. We go down to here. We select this. Say more. We go down to polynomial of order 2. Of order 2 means quadratic. If it is order 3, it's cubic equation. So this is order 2, so it's quadratic equation. Now, for us to get we'll now click this display equation on chart. So we'll just click this display equation on chart. We'll move this to this point. So this is a solution to that first equation, that first question 3. This is a solution, meaning, let me come down again and bring this to this area. Now that means our A, our B, and our C. That is the coefficient. This is the coefficient of x square, y, x square, x, and the constant. So the x square, what we got from the Trendline equation is 2.193. For B, we got 3.3786. For C, we got 4.262. We center them. And we bold them and make them big. So this is a solution. This is a quadratic equation. This value here is a quadratic equation. Now, having done that, let's go over to this other one. They said the data in problem 3 fits the equation this y equal to a. Okay, now let's rename this problem 3. Now click this to add another cell. Right click, rename it this problem 4. Now what I'll do, just copy this value here, come here, and just paste it. Now to use the LINEST, using LINEST to find the parameters a, b, and c. Now for us to use LINEST now to find these parameters, what I'll do next is to move this down. Or I can, let me say right click, I can just click this and insert one row, just like what they said here. Add a row to your sheet to complete it. Okay, that is a different question. Now I'll add a row. I'll call this x square. So x square, just put x2, select this, go to font, I will not say superscript. You can look at it, superscript. Now this will not be equal to this is b1. This is b1 raised to power 2. Now I will not copy this down there. So now this is a big plus with a hollow inside, but if I bring it to this point, it becomes dark plus. So I will select it. If I select it and draw it down, it will copy this formula related to the cells. Now if I go from here to here, this cell will now be C1 raised to power 2, which is here. This, it will be referencing this C1. The same to all of them. So it will just copy the formula and reference the upper cell, because this formula references this upper cell. So we have gotten our x squared. So to use LINEST, now you have LINEST. So you have A here, you have B, you have C. Now let me center them, make it bold, and it. So let me just come here, select this. I want to use the LINEST based on what was said here, that I should use LINEST to find the parameters A, B, and C. So using LINEST to find these parameters, what I'll do is to just type equals sign, then spell the LINEST. Okay, look at it is there. I press the tab key. Pressing the tab key, they say known y. So these are the known y. I'll just select it, select the row, the range. I haven't selected the range, I'll just say comma. The next option was a known x. These are the x value and the x square values. These are the known x. Now we'll just say comma. Now b is set to equal to 0, which is false. B is calculated normally true, so I'll select the true option. I'll press the tab key. I'll bracket close. I don't need the statistics. Now bracket close. Now I will hold the shift key, the control and the shift key, and I'll press enter. So this is it. This is the result. When you check this result, it's just the same thing with what's gone here. Now the next question was, they said, okay, add a row to your worksheet to compute the slope of a function at each point. Now let's go back to what we're doing. So we were asked to calculate the slope. Let me just bring it down here. I'll do that. Copy this, the x value, come down here. Let me just put it there. I'll paste. I'll copy the y value. Come here, paste it. Now let me just add some values from here up to 4. Let me add some values. Let me insert some columns. Now I needed to add something from here to here. Let me just say this cell, I say this cell is equal to, that is P1 is equal to Q1, which is 3.2. Now before I proceed with this option, let me calculate the difference between this R1 minus Q1. The difference is 0.9. So this is a step value. So the step value of 0.9. So I'll start from here. I'll just say this is equal to the P1 is equal to Q1 minus 0.9. So I haven't gotten this. I can copy down the formulas down to this point. Now we have minus 1.3. Now what is the difference between this and this? Okay, let's say this and this. So let me see the difference here. I have equal to K1 minus J1 is equal to 0.9%. Now the difference between this and this, let's see if it was okay. It will not give us 0.9. Let me check. Have it will just give me 0 minus it will give me 0.3. So L1 minus K1 will give me what? 0.3. So the difference here is not the same. Now using this equation, this derived equation here, I can calculate for this. I can calculate the estimated value here. I can calculate the estimated value. Let me delete this. I can calculate the estimated value here. What will I do to do that? I will not say this. How to calculate this? Having known that y, let me just go back to this place. Having known this formula, let me just go. Okay, there's no need to copy it. Let me go back. This should be equal to, the y is equal to a which is this. Okay, let me use name define tool. Come here, go to formula tab, create from selections, just select it, top row, but the top row is A, B, C, so I just say okay. So that's created. Now I'll just say L1 will be equal to A, that is A, because see it has this, that cell is active now, it has been selected. As I type in A, not that is active, it has been selected. Say A times this value up here A times this value up here, which is x, so x squared, so x raised to power 2 plus b to select the next, to select b times the same L1 is the x, the x value of L1. Now say plus C, press the tab key, you enter. Now we've gotten this value, we can copy it down to this point. So we have gotten all what we needed here. I haven't done that. Now let me just do the slope that we were asked to do. We'll just type slope. So slope is the same thing, is equal to delta y divided by delta x. This is slope. Slope is invariably, now let's say we have this value here. Let me select it and copy it down to this place. Okay. Copy, gives no copy. Let me see, can paste. Let me see what I'm pasting. I'm pasting anything. Let me copy. Is that copy? Wow. Okay, let me select it and say Control C, come here, let me paste it, C, okay, works. Now, so for the slope, this, let's say this, at this point, now, we're looking at, let me say for instance, let me move this back, space this, call this, let me call this backward. This is a backward slope. Backward slope. Let me call this central slope, and forward slope. So you can also check spelling. But having selected that, you can just press F7 to check spelling. Say okay. Now I've checked that, so now let's go back to this. You have slope, we want to look for slope. Now for backward slope, central slope, forward slope. Now for backward slope, now you are assuming here this point is your y0 and this is your y1. Now this is your x0 and this is your x1. So now for backward slope, you have here y0 minus y1 all over x0 minus x1. This is the slope, the backward slope. Now the forward slope, you're assuming here is your y0, here is your y1, here is your x0, here your x or x1. So the forward slope will now be y1 minus y0 all over x1 minus x0. Now let me just clean this whole thing. Your central slope, you have your central slope. Let me now say here is your y0, here is your y minus 1, here is your y1, here is your x minus subscript minus 1, x subscript 0, x1, x subscript 1. Now your central will now be, let me say the formula for central. This is for backward, this is for central, for forward. So our central, which is the best so far, so it will be from here to here. Now you are at this point here. Now you are the center. No, the central now will be y1 minus y minus 1. That is y subscript 1 minus y subscript minus 1 divided by x subscript 1 minus x subscript minus 1. So that is for the center. Now the reason why I added some data is because the difference between 3.2 and minus 1.6 is not 0.9. 4.1 minus 3.2 is 0.9, minus 1.6 minus 2, subtracting minus 1.6 and minus 2.5, it will give you 0.9. So but from here to here it's not 0.9, so that is why I added some values here. Now let's calculate the backward slope. The backward slope from here, I will just say is equal to bracket open, the R1, R2, which is your y, y0, yes, minus your Q2, bracket close, divide by bracket open, x subscript 0, which is your R1, minus your Q1, bracket close, enter. So this is the value for the slope, the backward slope. The forward slope come here, is equal to the k, and let's put the parenthesis, brackets open, minus j2, bracket close, divide by bracket open, k1 minus j1, bracket close, enter. This is the forward slope. Now the central slope starting from here will now be equal to, now from here to here, okay, will now be equal to brackets open, L1, L2 minus J2, bracket close, divide by bracket open, Q, L1 minus J1, bracket close, enter. Now this is the value for the slope at this point. So I can now drag this to this point. Now I've gotten the slope at this point, the slope at this point, these 2 points, the slope at these 2 points. So this is how the slope is gotten. Now let's save this. Okay, now let me just save it. Let me save it. Let me call it problem. Problem 3 and 4. Now, haven't gotten the slope. use a liner here. So what's the next question there? The next question was for us to get add a row. Okay, calculate the slope of, compute the slope of the function at each point. Construct a tangent to the curve at point x equal to 3.2. Now, let me select this, press Ctrl C, paste it here. Now, we're asked to find the tangent at this point. Now, how to find tangents to a curve? Let's say we have a curve here. Let me say we have a curve like this here. Now, we're asked to find the tangent at this point. Now, let me just draw a line. Let me just drawing a line. Let me carry the line to that point. Maybe I didn't draw this properly. Let me delete it. Okay, I've deleted that. Let me now draw a line again. Let me now draw, let's say at this point I draw an arc. This form, where is now? Let me undo. Oh, no. Let me delete this. Now at this point, which is where x is equal to 3.2, that is, at this point is our x subscript 0 and y subscript 0. So this is a point of our, the coordinate here is x subscript 0, y subscript 0. Now at this point, let's say we needed to get the value at this points to be able to know the, now if you want to draw this equation, the equation of this tangent, with this data gotten, you can be able to calculate it. So now here now will not be, let's say here the coordinate here is x subscript 1 comma y subscript 1. Here is x subscript 2, y subscript 2. This is x subscript 3, y subscript 3, and so on and so forth. Now let's find an equation related to this point. Now, the known value, we know our x0, we know our y0, we knew our x1, but we don't know what our y1 is unknown, because this is a point on the tangent. This is a tangent. This is a tangent. So but the point x1 on the curve is known because we have defined the curve. It's known. We have defined the curve here. Now, but the tangent is not known. So we're looking for, okay, let me say this in subscript tangent, which is t1. So to not confuse you with this is t2, this is t3, subscript t3. So now I haven't done that, so we're looking for subscript t1. Now for subscript t1, you have something like this. For subscript one, so now let's assume, from here, let's assume that the difference between your x, the difference between that is from here to here, this slope now, the slope for this tangent will now be y subscript t1 minus y0 divided by, this value here is y subscript t1, this point, this y0 is this, because here is also y0, y subscript 0. So now this difference here is x1 minus x0. Now, assuming the difference between x1 minus x0 is h, now meaning that from here, let's say it has a constant difference for this case. Let's say for this case now, there is a constant difference here. Now let's say this is h, 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 this is h. So there is a constant difference. This is h, this is h. Let's assume there is a constant difference in between those values. Now, meaning that the slope, which is a dy all over dx, this, it will be equal to this. So we'll now say or dy, or change in y over change in x, will now be y subscript 1 minus y subscript 0 divided by h. Now let's say y is a function of x, so the y all over the x will be function of x prime, function of x will be expressed in this form. So meaning that you have function the dy dx will now be expressed like this. Now the unknown t subscript 1 minus y0 will now be equal to h. Okay, so now adding plus y0 to both equation, this will cancel out. You have y t1 is equal to y plus h. That is y0 plus h times dy dx expression. Now I can also say y0 is something as function of x subscript 0. So now I will now express this as f subscript 0 plus h f prime function. That's so. Now this expression, here now, this is the slope at x. Now since this is a straight line, since this is a straight line, a tangent at a point x0 equal to 3.2, so the slope at that point will be at the point where x is equal to at point x subscript 0. So we'll make f of we'll make the that is dy dx, which is f prime of x0. So we'll now have it to be at this point. So this is a constant. The slope is constant because it's a straight line. It's a tangent, it's a straight line. So here will be x subscript 0. Now you have here as x. So you have function of x subscript 0. This equation. This is we have gotten this unknown. So we're using this formula to get these values here. Now this is for just a step from here to here. So the value for two steps, let's say here, now from here, from this point, let me clean this whole mess so you understand what I'm saying. Now from here to here is just one step. So now for two steps, let's see what the formula looks like for two steps from here to here. Now from here to here, the slope, now you have y you have here to be this point to be x subscript 2 y t subscript 2 y subscript t2 to be at this point. Now at this point is x subscript 2 y subscript 0. That is at this point. So at this point you have x subscript 0 y subscript 0. So now the distance from here to here is x square s subscript 2 minus s subscript 0. So assuming the constants are the same, so here is 2h, 2 times h. Now here the difference between this, the height, the length between this and this is something as y subscript t 2 minus y subscript 0. Now the slope, which is the same thing as f of x 0, the slope is constant, is a straight line. So to have constant slope, and the value is this, the value of the slope is that we have calculated the slopes for each of those points. Now this is a slope at point x equal to s, and at point x is equal to 3.2, there is x subscript 0. Now which is this, so we're just saying f of x, now function, there is a first derivative function of x at x0 equal to 3.2 is equal to f, that is equal to function, the first derivative function of x subscript 0. Now that is what we're going to use. That is the slope of this tangent. So for two steps from the point where you have the tangent to the curve, so 2 steps from that point, the slope will not be y subscript t2 minus y subscript 0 divided by x subscript 2 minus x subscript 0 is equal to f, that is the function of the first derivative function of x subscript 0. Now this x subscript 2 minus x subscript 0 is something as let me write it down. X subscript 2 minus x subscript 0 is something as 2 times h, which is 2h. Now 2h, assuming from here to here is the same, from here to here is the same, which is 2h. Now in this case I would choose data where those values are the same, but if those values are not the same, I can just use the x value and make my input, just like as the formula is here. I use my x values. So I can also, because this one is given, this one is known, this one is known, This one is known, this one is not known. I can calculate for this using these values, these expressions here. I can do that without assuming this. Now, having assumed this, I will just, having assumed x subscript 2 minus x subscript 0 is equal to 2h, I will just say y subscript t2 minus y subscript 0 divided by 2h is equal to function, the first derivative function of x subscript 0. So so now multiplying both sides by 2h, I will have t subscript y subscript 2 mt2 minus y subscript 0 is equal to 2h times the function, the first derivative function of x sub 0, x sub 0. So now from this equation we can now add, let's say we want to isolate this, we add plus y sub 0 to plus y sub 0 to both sides, y sub 0. Now this will cancel out this. You have y sub t2 equal to y sub 0 plus 2h times first derivative function of x sub 0. So we have this. So you see, two step, you have 2 here, one step you have 1 here. So by deduction, 3 step will be y sub t3 equal to y0, y sub 0 plus 3h times first derivative function of x sub 0. So now I can just say this equal to the function of x sub 0 plus 2h times first derivative function of x sub 0. Now this is the same thing. Just write in this form. Now meaning for n term, that is y subscript tn is the same thing as saying y subscript 0 plus n times h times first derivative function of x sub 0. So this is the deduction. From deduction, that is what I got. Now if we're looking at the backward step, it will just be the same thing. Now you have here, okay, let me just say second two step backward. Here is the same thing as saying x subscript minus 2 comma y subscript minus t2. So let's work out this. Now we know the value here, we know the value here, which is this. Now moving from here to here, you have something like this. So now we want to get that value. So let's assume from our head, from our mindset, we're expressing everything in this form. Let's say the slope is equal to, now let's say we're using here, we're not, this is a backward flow, so the backward flow. So now from here, in this case, your x0, our x subscript 0 is greater than x subscript minus 2. Now if we now assume, assuming this, the difference between this and this is 2h. Now want to express it in this form, wants to say y, it will not be y0 minus y subscript minus t2 divided by x0 minus subscript x subscript, it will now be x subscript 0 minus x subscript minus 2. Now the difference between this and this is 2h. Is 2h. Knowing that this value is greater than this value, so it will be a positive value. You have y0 minus y subscript minus t2 divided by 2h. Now if we want to solve this equation, now multiply both sides by 2h, we have y subscript 0 minus y subscript minus t2, it will be equal to 2h times f, the function of the first derivative function of x sub 0. So now to isolate this, we'll add minus y0 to both sides. Now this y subscript 0 will cancel each other in the left hand side. You have minus y subscript minus t2 equal to minus y0 plus 2h times first derivative function of x of 0. Now here, if we multiply all through by minus 1, if we multiply all through by minus 1, so minus 1 times minus y subscript minus t2 will give you y subscript minus t2 will equal to is minus 1 times minus y subscript 0 will give you y subscript 0. So minus 1 times plus 2h times first derivative of x of s sub 0 will now give you minus 2h times f sub f first derivative function of x sub 0. So this is it. So meaning 2 steps backwards will give you this. 1 step backward, this value will be 1 step backward, this value will be minus 1. So meaning that this expression is a constant, is meaning that from this deduction this formula has been ascertained. Now let's go back to that. So we were asked to find the tangent at this point. So the tangent at that point, now let me just say tangent. Let me just write the tangent. The tangent at that point. Now the tangent at that point, the y, the first value for y at that point will be equal to this, value. Now for us to get this, say equal to, now let me come in. The formula we have here 0, we have here 1, because this is the first step forward. The first step forward is 1. The second step backward is minus 1. The first step backward is minus 1. The second step backward is minus 2. The third step backward. So let me just say, let's fill it up to this. Okay. Now, how many points do I have? I have 1, 2, 3, 4, 5. Let me remove this. I just need 5 points. I don't need 5 points. Even I need just 4 points or 2 points to draw this tangent. So let me just make it 4 points. Okay. Let me increase it. Let me increase it to, let's say 5 points. Let's say 6 points. So to draw that. Okay. Now up to the 6th point, the value of now from here to here, the difference between the x value is a constant. That is the difference between 4.1 minus 3.2 will give you the same value from, that is 4.1 minus 3.2 is same as 3.2 minus 2.3. 2.3 minus 1.4 is the same thing. It will also give you 1.4 minus 0.5. It will also give you the same thing. 0.5 minus 0.4 will give you the same thing. But where we want to do is from here to this point. So let's find the value, the tangent. Now here is the n value. Now let's center them. Go to home, press we'll press the center button. So now to get this point, it will be equal to, this is your y value. Now let me just make a point. Let me just copy this formula. Let me write it properly. Let me write it properly. Y equal to f of x0 plus n h dot f of now let me use sniping. Let me just select this, copy, let's go here, let me just paste it. So this is what we're going to use to solve for the values of y for various points. So for this point, I will say y, the tangent at that point will be equal to, to calculate this now, let's start from here. I will say this is equal to our f sub 0 is at x equal to 3.2. Just select this, I'll fix it by pressing F4. Just now since I'll put the dollar sign behind the Q, I'll fix the Q behind the 2, I'll fix the 2. So I've that value now, which is 37.5, which is the y value at x equal to 3.2, has been fixed. Now, having been fixed, I will now say plus, this is our n, the n value, which is this n in this formula, plus n times our h is a constant, because from this point down to this point the h is a constant. That is, so I will just choose one of them, which is this. I will say which is this is R1. I'll fix it by pressing F4 minus Q1. I will also fix it by pressing F4, then bracket close. Now times the slope at x equal to 3.2. The slope at x equal to 3.2 is this value here. So, well, this value is a constant, so I'll fix it by pressing F4. So I fixed it. Now this is the value we go here. Now if I now copy this down here, you see that the value of y here should be the same as this. It should be the same as 37.5. So if it's not the same, then there is a problem somewhere. So let's copy down the formula. Let me copy the formula by dragging. Now if we drag from here, it will copy the formula. But if you put it here like this, okay, if you bring it here, we're moving. This sign means moving. This sign cannot copy, cannot move. It will only just highlight the whole of this. Now, but if you select here, you come to this square mark here, then you have this cursor changing to black cross. You just select move. You're copying the formula inside there. See, this value is the same thing as 37.5. So meaning that what you did was correct. Now let's plot this whole thing to see if we get what we did. So now to see if what we did was correct. So what I'll do now is to plot this quadratic equation first. Now let's go. Let me just select from here to this point. Insert the slope. I'm using this. I'm selecting that button. Now then come down here. Let me edit this. Let me say the marker. Let me make it solid. Sorry, the marker. Select this. Okay, let me leave it at a circle. Let me increase it to 8. Now it's good. Let me say 0 fill. What remains of this? Let me increase the thickness a little. Let me add a line. Let me say solid line. Okay. Now this is the graph. Let me look at that line again. Let me just increase the thickness of that line a little. Now, okay, no. The line is supposed to have. Don't need to increase it so much. Let me leave it at this. So let's now draw this tangent at that point. So what I'll do, I will select from here, from arrow 1 to arrow. Let me select from this point, M1 to arrow 1. I'll press the control key, select M16 to arrow 16. Okay, no, sorry. I needed to select this first. Go to design, tab, press select data, add another series. I'll call this series I'm adding tangents. I'll call this series tangent. Then the X value, I'll select from here to here. The Y value, I will select from here to here. Now I'll press OK. I'll press the OK button here again. Now this is the tangent. I'll select this tangent. I haven't selected it. I will say right click. Okay, let me show it again. So right click, format data points. Oh, this is just only one data point. No. Let me see. let me now for the mark say none. Okay, it's just that one that goes off. Let me, okay, this one has selected all of them. I'll come here, select the marker option, say none. Now I needed to change this line to, let's red, the color red. Let me go select line, solid red. Let's say black. Now it's done. So this is a tangent. So let me can select this and move. Can select this. I want to move the chart area. Okay, move charts to new sheets, so the chart will be visibly enough. So now if you look at these charts now, you see that this tangent just flow past this. So let me just add legends of this. Now I can let me edit this. Let me call it, let me just say this, let this series, I will just edit this value here. Let me go back to 4. I will just select this point so that will be y. Change that y serial 1 will be y. So it's y. So I haven't selected that y value, y over here. So that is it. Now this, I can change the chart to quadratic equation. This can also be done in this sheet. Why it was in this sheet, I can do that. Change this to, let's say, quadratic equation. So that is that. So I'm done with this. Let me move this chart from here to this point. I can also move it by saying right click, move or copy. I was move it to the end. That is it. It goes to the end. I can drag it. If I drag this to this point to be here, if I can drag it back to the back, that is it. Back to the end. That is it. So let me save. Go back to this point. Let me bring this down. So we just drew the tangent at this point. That is done. So let's close. Let's save and close. So if you like this video, please subscribe to my channel, hit the notification bell, so next time if I do a video, you will be the first to watch. Thank you.